Okay, so the first thing is you have to satisfy this first. Okay, when you say on the basis of central limit theorem, what does that mean? You still remember what is your central limit theorem? Yes. You still remember what is central limit theorem all about? So central limit theorem is very important. For this case is what? You make sure all the sample mean and sample proportion, the shape of the sample mean and sample proportion must be normally distributed.
Supposed to be having orientation here. Class? Is there a class at this time?
I'm having on my course.
Oh, okay. Oh, I'm so sorry.
Okay, the shape of the distribution of, so we have the parameter of interest here, that is sample means or sample proportion, that we will do it in another part. Okay, the shape of the distribution of sample mean or sample proportion must be normally distributed. So for this case, when you say must be normally distributed, what does that mean? If you go back to your central limit theorem again, there are two parts of it. Am I right? First of all, you have to look at how is the nature of the population. If the population is naturally occurrence thing, that means it is definitely normally distributed. So you don't have to care about the sample size. But if the population is not normally distributed, especially proportion, then the sample size, according to the rules of thumb, it must be more than 30 in order for the sample proportions distribution to be normally distributed. So whenever you talk about confidence interval, first of all, our basis is on what? Central limit theorem at this level. You can base on other theorem. That is out of our syllabus. So you must justify whether it satisfies central limit theorem or not. That is the first thing. So that means the choice of your sample size is very important. Clear? Okay, second thing. So the basis of it. So this is the first important thing. That's why when you write your folio, you must explain central limit theorem clearly first, then how this lead to confidence interval. Okay, so this is the first issue you must settle. So after you settle the first issue, so now you have to settle another issue that is called level of confidence. This is your second issue. What do you mean by 95% confidence? What do you mean by 95% confidence level? What do you mean 95% confidence level? Okay, this is very, very important. The 95% confidence level is not probability. It means that 95 samples out of 100 samples will contain the population parameter of interest. That is the parameter of interest. That means can be population mean or population proportion. Okay, 95 samples out of 100 samples we take will contain the population parameter of interest. Okay. So clear? So you have to, when you talk about confidence interval, you want to explain how this confidence interval come about. You have to first talk about what shape of distribution are we interested in, so that you can do calculation, if not how to do. Then at what level? At different level, it means different thing. So what do you mean by confidence level? That is what I want to tell you. Okay, so now, how do we come up with confidence interval? Okay, like for example, the one given. So what we do is, okay, we assume that, okay, someone has made a claim. Someone claimed that the protein content in 1 liter carton of milk is 39. So this is the claim. So that means we have a problem. So now you want to solve the problem. So you are going to use the confidence interval to solve this problem. So there's someone, there is a claim. So always when we use confidence interval, the claim is the problem. We call it the problem statement, the claim. Someone claimed that the claim is 39 grams of protein in 1 liter of milk. Okay, so this is someone claim. So how am I going to do this? So I'm going to get a sample. So a sample, so I count the I got 38 grams. So this is what we call the point estimator. Point estimator. Okay, so what is the sample size in this case? So you have to base on whatever is it. So you have to mention your sample size. Okay, so I will say a sample of sample size Okay, I say 35 for example. For example only. Okay, sample size of 35. That means I take 35 carton, everyone I measure their amount of protein, the weight of the protein inside there, and I find the mean and I got 38 grams. Okay, so now, so my sample size is large enough. Okay, so now, how am I going to use this? Okay, so I want to find my 95 confidence. Okay, so done. So always you start with the problem. Okay, this is the problem, means the claim, problem statement. Then you get the samples, you determine your sample size, then you get the sample mean. That sample mean as a point estimator. Then we determine our confidence level. Okay, then based on central limit theorem. Okay, so now, so based on central limit theorem, my sample mean distribution, since my sample size is large enough, my sample mean distribution will be normally distributed. Okay, yeah, and according to central limit theorem, the sample mean distribution, the mean will be equal to the population mean, correct? And this one, we put it as the claim. The mean of the claim as the population. Hold on. No, not the mean of the claim. Okay, so this is our point estimator. And the standard deviation of this is equal to the population standard deviation divided by square root of n. Okay, now I want to let you know, since we don't know what is the population mean, so we take this sample mean as our point estimator. So 38. And we always use this symbol to represent it. Are you clear? That's called the point estimator. And if you got the population standard deviation, you use the population standard deviation. But in real life, you definitely won't be able to get the population standard deviation. So you assume this sample standard deviation this sample standard deviation as the population standard deviation. So this is one of the assumptions that you make. So listen here. The sample mean or the sample proportion will be the point estimator. So then now you are trying to estimate the confidence interval based on the 95%. So now how we get the 95%? So we transfer this to z-score. Okay, when you talk about 95%, so it's a bell shape, Okay. Yeah, it's 95%. So don't take it as probability. I told you what is the meaning of 95% confidence level. That means out of 100 times, 95 times, it will capture the population's mean or population proportion. Depend on what which one are you talking about? Can you tell me what is the value of Z1 and Z2 from your calculator? Quick. You use inverse norm. Do you know how to use inverse norm? Okay, Andy, City, can I have Z1? Choose center, inverse norm, area 0.95.
Negative 1.96.
And here?
Positive 1.96.
So everyone must learn how to find the Z value based on the confidence level given. Yeah. Hello? Are you clear? 0.95, 0, 1, and center. Okay, so now, so can you tell me what is the lowest value here? And what is the highest value possible? So lowest, predicted, mean. May I know what is the answer? What is the lowest predicted mean? And the highest predicted mean? Based on the formula? Hello? Can someone give me for this case? You have to go back to your chapter 8. $38 minus, did they give us the standard deviation? Oh, they didn't give us the standard deviation, so I cannot. Okay, 38 minus what? Okay, I give you the standard deviation. Okay, I give you the standard deviation. Standard deviation of this sample is equal to okay, I give you 2 grams. Okay, now you try to count. We know that our Z is equal to, Z equal to what? X, hello, X minus mean over standard deviation, correct? So you try to count and see. So, can you? Yes, have you counted the lowest? 34.08. Whatever, so Thaddeus got 34.08. Highest? 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 Thaddeus?
We are still calculating.
You're calculating. Xin-Chi or Xin-Ren, have you got the highest?
41.92.
41 ah?
Yeah.
30? Highest what?
41.92.
Oh, 41.92. You are using the program ah?
No.
No, you are using the formula, correct? Okay, look. So how do we get this? So you see, highest minus 38 divided by 2 over root 35 is equal to 1.96. That is how you get 41.98. That is how you get 41.98. Correct? And lowest minus 38
Miss, I
divided
think
by...
I'm wrong.
Why you are wrong?
I used 2. I didn't use 2 over square root 35.
I think Thaddeus is also wrong, lah. Am I right? Hello? Because this is simple mean ma, 2 over square root of 35 is equal to negative 1.96. Hello? You are using this to predict. Yeah. Why you use negative 1.95 and not 1.96? You round off, Bram, round off to 3 significant figure. Round off to 3 significant figure, okay? Okay, can I have, what is the highest predicted value? Hello, student, quick. I give you the formula already, you still cannot calculate and let me know the answer. Huh? 38.66. Okay, lowest. $37.34. Okay, look. So that is how we do. Okay, afterward, I will show you how this formula come about. So that means, it means like that. Okay, this is my predicted. Okay, look. Can I move to the other side? That means, based on the sample mean of 38 gram, I make a prediction of the true population mean. Wait, that is, it can go as low as 37.34. And it can go as high as 38.66 gram. So based on this sample, there is sufficient evidence to reject the claim. Because the highest possible predicted mean weight is 38.66 gram, which is less than 39 gram. You see, based on this sample only, another sample, I may have different story. Do you get me? So all these are called evidence-based. My sample may be different from your sample. Why? Because sample is part of the population. We won't be able to get the exact sample mean for everyone. But I know that for this case, I have 95% confidence. That means out of my 100 samples, 95 samples will get will predict a confidence level, confidence interval for true population mean that will capture the true population mean. That means, in another word, out of 100 times I find the confidence interval, 95 times I will reject. I have sufficient evidence to reject the claim. You get what I mean? Hello? So, confidence interval for the population is a prediction. What you are based on? You base on a sample. And at a certain level of confidence, on the basis of central limit theorem. That's why we can use Z-score. Are you okay? Do you need me to derive the formula for you? Do you know how I justify this claim? I can draw my confidence line interval to represent the confidence interval, 37.434 gram, 38.66 gram. So this is my confidence interval. The claim is here, 39 gram. Hello? Now you have a better understanding of the whole thing? Okay, I want to derive that formula for you by using not the textbook method. I use my own method so that you can figure out it better. Yeah? So now you have this. So since we are talking about sample mean, I just based on the sample mean first. Then after that, when it comes to proportion, I show you the proportion part. Okay, now. Okay, we assume this mean is a sample mean that we got. Okay, then the standard deviation divided by square root of n. Okay, I will talk about this more as we go from question to question. So this will be the lowest possible predicted. This will be the highest possible predicted. Okay. We transfer this to become a standard score. And this is the highest possible, lowest possible. So to get Z1 and Z2 all depend on confidence level. And you know that you have to use inverse norm. Whatever is it, 0, 1, and here is center. So you will get a value, I call this value Z in your book. They call it the Z score. Okay, I call it Z alpha. In your book, they call it Z alpha. Okay, Z alpha. So therefore, the lowest is equal to, okay, I don't want to start from lowest minus X bar over standard deviation divided by square root of n is equal to negative Z alpha. Am I right? So Z alpha, that means depend on if the confidence level is 95, Z alpha will be equal to 1.96, sorry. So if the confidence level is 90, then your Z alpha will be small, bigger. Yep. If 99, smaller. If 99, it will be much bigger. So therefore, your lowest is equal to minus Z alpha standard deviation over square root of n. So from here to here, or from here to here, okay, if you look at your textbook, there is another term used. So you go and look at your textbook and how to use it. Okay, there is a term for it. So that is the lowest. So the highest, so I can straight away, the highest will be equal to, since here is a plus, so that's how you get your predicted confidence interval. Okay. So the confidence interval, the formula come out to be like that. Your sample mean, the one of the particular sample mean that you have, minus the standard score, okay, time by standard deviation divided by square root of n, and here okay. So this is a formula for confidence interval. Okay, now how to use your GC? I might as well complete everything for you. Okay, GC, we use just now, we have our sample mean we get is 38. Our sample size is, what is it? Our sample size is 35. Our population standard deviation we don't have. We assume it is a sample standard deviation, which is 2. Okay, So now you please take out your graphic calculator. Go to second verse. No. Where is it already? Oh, go to stack. Please go to stack. Okay, press this button, stack. Go under test. Scroll down. Z interval, number 7. Select number 7, Z interval. Okay, select that number already, Z interval. Okay, now input. You go to stack. Enter. Okay, standard deviation. You key in 2. Sample mean. You key in 38. And you key in 35. Confidence level, we talk about 95. Okay, make sure it's 0.95. Then calculate, enter. Do you get the answer? Hey, wait. How come I got different answer one? Oh, okay, this one is wrong, 38. Okay. N is 35, I didn't change. I asked you to change, I didn't change. So you get that? You get in the bracket 37.337 and 38.663. Isn't it exactly what we calculated here? See or not? So your calculator can do that. Z interval only, listen here. Z interval is to find true is to predict true population mean based on a sample mean. See? You can either use this formula or you use this. Is this formula important? I will want to tell you that it's important. Okay, tomorrow I will talk further. So now, and you please look at page 271. What do you mean by margin of error? What do you mean by width? I will continue that tomorrow. So I have tried my best to explain to you. I have consolidated whatever you have in page 269 and 270 today. So you can follow the formula given by your book, but it's going to make you go crazy because you are dealing with inequality. when you do the changing, you have to be very, very careful when you change the sign. You can try to understand whatever given in the textbook there. So I will prefer, for me, I will prefer to come up with the formula using this method. Using this method. So that it's easier for me to comprehend. It's not that I cannot do whatever your book is doing. I can. It's just that it will be more difficult for you.